Hello everyone, welcome to our lesson on angles. We begin with some quick definitions. An angle is formed by rotating a ray around an endpoint. The angle is the amount of the ray that is rotated. So let's think of this ray as this red colored ray line horizontal. If we take this ray and rotate it anti-clockwise to this green ray position, we form an angle. The starting side of an angle is called the initial side. So wherever we start, that's the initial side. The ending side is called the terminal side, just as in the diagram. On a graph, the initial side of our angle lies on the positive x-axis, so it's always horizontal, and that is the standard position. Coterminal angles have the same initial and terminal sides regardless of the direction of rotation. For example, in this angle, we're rotating anti-clockwise, side 1 to side 2, initial side to terminal side. In this angle, second angle, angle 2, we're rotating in a clockwise direction, but as long as they end up in the same positions after rotation, we say they are coterminal. Positive angles have an anti-clockwise or counterclockwise rotation. Negative angles have a clockwise rotation. So if you see an angle like negative 45, that means that we're starting right on the horizontal axis and rotating 45 degrees clockwise. A full turn is 360 degrees, a half turn is 180, quarter turn is 90 degrees. To find positive coterminal angles, we add 360 or 2 pi in radians, or multiples of 360 until we get positive angles or more positive angles. And to find negative coterminal angles, we add negative 360, or in other words, subtract 360 degrees or 2 pi radians until we end up with negative angles. Let's look at a couple of examples. If an angle is in standard position, find 2 positive coterminal angles and 2 negative coterminal angles. Here, we're simply finding positive angles. If we start with a positive angle, then we just add 360 to that positive angle. So it's 150 plus 360, and that will give you 510 degrees. If we take this 510 degrees and add it to 360 again, we get 870 degrees, and that is your second positive coterminal angle to 150. Alternatively, you could have added 150 plus 720. That is twice 360. So that's another way of doing it. With negative coterminal angles, we're going to be subtracting 360 until we get negative angles. In this case, 150 minus 360. That gives you negative 210 degrees. So that's your first negative coterminal angle. We take this negative 210 and subtract 360. We have negative 760 degrees. That's your second negative coterminal angle. Now we're asked to find 2 positive and negative coterminal angles for negative 40. We do the same thing, negative 40 plus 360. That should give you positive 320 degrees. And then if we take that positive 320 degrees, add it to another 360, we get 680 degrees. So that's your 2 positive coterminal angles there to negative 140. And then for negative coterminal angles, we're subtracting 360, so negative 40 minus 360, that gives you negative 400 degrees. And subtract another 360 from negative 400, we end up with negative 760 degrees. And so those are your 2 negative coterminal angles for negative 40 degrees. Now, number 2, we're asked to find a coterminal angle to these angles, negative 5 pi over 6 and 13 pi over 2 in this interval, which means that they are both going to be positive and be restricted to between 0 and 2 pi. Now, how do you find coterminal angles between 0 and 2 pi then? Because negative 5 over 6, 5 pi over 6 is a negative angle we want to add. Since we want to get a positive angle, we're going to add 2 pi. But it would be nice to convert this 2 pi to something over 6. So let's convert it to 12 pi over 6. 12 pi over 6 is the same as 2 pi, so let's make that 12 pi over 6 so we have the same denominator, and then we can add right across. So this is negative 5 plus 12. It's going to be 7 pi over 6, and then check if it's between 0 and 2 pi, and then that's checks. So that is our answer, 7 pi over 6. Now for part B, we have 13 pi over 2. And we want to get this to between 0 and 2 pi. But because 13 pi over 2 is bigger than 2 pi, because 2 pi is the same as 4 pi over 2, now we want to minus 2 pi until we get this to be between 0 and 2 pi, the final angle to be between 0 and 2 pi. So make this 13 pi over 2 minus 4 pi over 2, because 4 pi over 2 is the same as 2 pi. 13 minus 4, that's going to be equal to 9 pi over 2. This is still bigger than 2 pi, 9 pi over 2, so we got to go next step and do 9 pi over 2 minus another 4 pi minus another 4 pi over 2. That gives you 5 pi over 2. It is still bigger than 2 pi, so this is bigger than 2 pi and 2 pi. Both of these are bigger than 2 pi. So I have to continue 5 pi over 2 minus another 4 pi over 2. And here we end up with pi over 2. And this angle pi over 2 is between 0 and 2 pi. So that's your answer. Checks right there. Okay. So let's talk about radian measurement. A radian is a measure of a central angle of a circle subtended by an arc equal to the length of the radius. So let us say our radius was of this circle was this distance here in red from the center to the circumference. If we take this exact length and then measure it along the circle, or an arc becomes an arc of the circle, and this measure is 1 radian. So a radian is a measure along the circumference of the circle that is exactly equal to the distance from the center to the circumference. So that is 1 radian. Relationships. 180 degrees is equal to pi radians, and 1 radian would be equal to 180 degrees over pi. So 1 degree would be equal to pi over 180 radians. Right? Now let's do some examples. First example is that we're trying to convert 330 degrees to radians. So know what we know about converting from degrees to radians, we will multiply by pi over 180 to get from degrees to radians. So let us do it. 330 times pi over 180, we can either just put that in your calculator, or we can just simplify this, and when we simplify it, we get 11 pi over 6. 11 pi over 6. That's the answer. Again, converting from degrees to radians, negative 225 degrees multiplied by pi over 180. That becomes negative 5 pi over 4. Okay? Now, other way, converting from radians to degrees. Number 6, we have negative 2 pi over 3. This time we multiply by 180 over pi, but we're going from radians to degrees. And this will give us negative 120 degrees. And converting from radians to degrees again, 3 pi over 4 times 180 over pi, and that will give us 135 degrees. Okay, let's talk about arc length. Arc length, we're given a circle of radius r, the length s, that's arc length s, intercepted by a central angle theta. Notice here that theta is in radians is given by S is equal to R theta. So in the formula, R theta is in radians. And this we get from the circumference of a circle, which we know is 2 pi r. Then S is equal to theta over 2 pi times 2 pi over r, and that will be equal to R theta. So that's where we get S equals to R theta from. So again, theta is in radians. So if we're given the angle in degrees, we must convert to radians in order to use the formula. Next thing we talk about is the area of the sector of a circle. We denote that by letter A. It's given by the formula A is equal to 1/2 r squared theta. Again, we're coming from the area of a circle, taking the part of the area of a circle related to the sector. It'll be theta over 2 pi times pi r squared, and that is how you get your 1/2 r squared theta. Okay, again, pi is in radians, so if you're given it in degrees, you must convert it to radians in order to put in the formula. If you're given in radians, then you just go straight ahead and plug it in. Example, a central angle theta is subtracted by 10 centimeters long on a radius of 4 centimeters. Approximate the measure of theta in degrees, so S is equal to R theta. So we know from this that S is equal to 10 and R is equal to 4. So we plug those in. 10 is equal to 4 times theta. So that means that theta be equal to 10 over 4 equal to 5 over 2. Well, what measure is this in? This is in radians, right? And we want to get it to degrees. Radians. So in order to get it to degrees, convert to degrees, because that's what the question asks us to do, right? In degrees, we multiply by 180 over pi. So 5 over 2 times 180 over pi, and you will have like 450 over pi degrees, because many times we like to write it as decimals. That will be 143.24 degrees. Okay, now let's find the area. Area is equal to 1/2 r squared theta. It's going to be equal to 1/2. R we know was 4 squared. Then theta is the one that is in a radian. So we got to take 5 over 2 radians and put that in. So that's 5 over 2, and you get 20 centimeters squared. Okay, number 10, find the length of an arc of a sector which radius is equal to 9 and central angle measures 120. So here we have it in degrees, so convert to radians. And we could either do that aside or we could do it while we're working through, but we need to convert to radians. So converting to radians, we have S is equal to radius, which is 9. Theta is 120 degrees, but we're converting that to radians, so that's times pi over 180. So 120 times pi over 180. And then when we do all that, we should end up with 18.85 centimeters. 18.85 centimeters. Okay, the area of a sector has an area of 5 meters and a radius of 2. So what we do is that we plug in 5 for area is equal to 1/2 r squared, which is going to be 2 squared, times theta, right? And so that is so 5 is equal to 2 theta, and so theta will be equal to 5 over 2, and this is in radians. Okay, so that is the answer.